This is our bio breakthrough presentation on CRISPR, a genetic solution for maple syrup urine disease. My name is Kenny.
My name is Andy.
And I'm Varrock.
Alright. CRISPR is a revolutionary gene editing tool that allows precise modifications in DNA. Maple syrup urine disease is a rare genetic disorder that disrupts amino acid metabolism. Our goal is to explore how CRISPR can provide a potential cure for maple syrup urine disease. Alright, to understand maple syrup urine disease, it's a metabolic disorder caused by genetic mutations in specific enzymes. It prevents the body from breaking down branched chain amino acids. It leads to toxic buildup in the blood, causing neurological damage. Symptoms include largely vomiting, seizures, and a characteristic sweet-smelling urine.
So for impacts of maple syrup urine disease on communities, it is more prevalent in Mennonite, Amish, and some indigenous communities due to their genetic founder effects. It affects about 1 in 185,000 individuals worldwide, and patients require strict dietary restrictions and medical monitoring to manage symptoms. Maple syrup urine disease is caused by mutations from these genes as such, and these genes encode for enzymes responsible for breaking down the branched chain amino acids that we mentioned earlier. Mutations then lead to dysfunction of the branched chain alpha keto acid dehydrogenase complex. For the science behind it, CRISPR-Cas9 is a gene editing tool that can precisely modify DNA sequences. It targets the faulty genes, and Cas9 enzyme acts as a molecular scissor to cut the DNA at the mutation site. Corrected gene sequence can then be inserted using repair mechanisms. For nucleases, Cas9 is a nucleus that cuts DNA at a specific sequence. For PAM sequence, Cas9 recognizes specific DNA sequences adjacent to a protospacer adjacent motif, the acronym PAM, to ensure precise cutting. Chemical and functional differences between DNA and RNA. DNA is double-stranded, while RNA is single-stranded. Uracil versus thymine. RNA uses uracil instead of thymine for pairing with adenine.
Here are our game changers versus our dilemmas. First of all, it provides a potential permanent cure instead of lifelong dietary management. It also reduces metabolic crisis and improves overall health outcomes. It also decreases dependence on medical interventions and dietary restrictions. It can also be applied to newborn screening programs for early intervention. But some of our dilemmas are accessibility. Will CRISPR treatment be available to all affected populations? Some risks or potential off-target effects of unintended genetic changes. Ethical concerns. Should gene editing be used for inherited diseases? And regulation. The need for strict guidelines to ensure responsible use of CRISPR. The future of maple syrup urine disease treatment. CRISPR has the potential to revolutionize treatment for maple syrup urine disease and other genetic disorders. Balancing scientific innovation with ethical responsibility is crucial. Ensuring equitable access and safety will determine CRISPR's success. And here we have our model. Thank you for listening.